Welcome to momedaram. In this video, we will see ArrayList class. ArrayList class is one of the implementation class for list interface. An ArrayList is like an array which can grow in memory dynamically. It means that when we store elements into the ArrayList, depending on the number of elements, the memory is dynamically allocated. The array list is implemented by using global array, that is, the underlying data structure is global array. This array list allows duplicate objects. Elements will be stored according to the insertion order. Array list allows heterogeneous objects. That means it will allow different type of objects also it will allow. Null insertion is possible. We can able to insert the null values also. We can use collection to store and transfer objects from one type to another type. To support this, every collection class internally implements serializable and clonable interfaces. Why serializable interface is implementing means to transfer the data securely from one type to another type. Why clonable interface is implementing? Generally, when you transfer the data from one type to another type, they will not actually work on the actual object. They will clone the object and then they will perform the operations on that cloned object. That is the reason clonable interface is implemented. ArrayList implements random access interface so that any random element we can access with the same speed. In collections, ArrayList and vector class, these two classes are implementing this random access. If you see in this diagram, java.util.ArrayList class implementing list interface and also implementing random access interface, also implementing clonable interface, serializable interface. So we can say ArrayList implements list interface, random access interface, clonable interface, serializable interface. This random access interface is a marker interface. Marker interface means it will not have any methods in it, and this random access interface is available in java.util package. Next we will see constructors of ArrayList. Constructors of ArrayList provides many ways to create the ArrayList objects. So if you want to create an object, most of the cases in Java 95% of objects are creating using new keyword. For creating ArrayList also we will use new keyword. So there are some constructors are there for ArrayList. We will see one by one. ArrayList AL is equals to new ArrayList of. This constructor is used to construct an empty list with an initial capacity of 10. By default initial capacity is 10. If you see in this example, we have created an ArrayList object. ArrayList AL is equals to new ArrayList, and we are applying isEmpty method on that ArrayList object. When you run that, it is giving true. So by using isEmpty method, we can able to check whether an ArrayList object is empty or not. Once the ArrayList object reaches its max capacity, a new ArrayList object will be created with new capacity, that is current capacity into 3 by 2 plus 1, and all objects will be shifted to the newly created ArrayList object, and so on. Let's take an example. We have an ArrayList object and it is having 10 elements. So ArrayList also index starts from 0 to n minus 1. So here we are having 10 elements A, B, C, D, F, G, H, I. So if you want to add any new element to this array list, what will happen? When you try to add a new element, the new ArrayList object will be created with the capacity of current capacity into 3 by 2 plus 1. Current capacity is 10. 10 into 3 by 2 is 15. 15 plus 1 is 16. So the new array list object is created with the capacity of 16, and all the elements in the existing object will be array list object will be shifted to the new object. After that, the whatever the object we are planning to add, it will be added into the list at the end. So whatever this array list object is pointing to the existing object, it will not point into that object. Next it will point to the newly created object, and the existing object is eligible for garbage collection. The next, if it is reaches its max capacity, if we added few more elements and if it is reaches its max capacity, the new array list object will be created, and the current capacity will be 16 into 3 by 2 plus 1, that is like 8 3s are 24 plus 1 25. The new object will be created with size is 25, and all the elements will be shifted, and this object will be eligible for garbage collection. The next constructor is ArrayList AL is equals to new ArrayList of initial capacity. It will accept int initial capacity. What is the benefit of this constructor is, in the earlier case ArrayList AL is equals to new ArrayList. For every time, like whenever it reaches max capacity, a new object is created. So if you are sure about the capacity, how much elements it will be take, we can able to create that array list with that capacity. So this constructor creates an empty list with the specified initial capacity. In this also, once we are able to store all the elements, and if it reaches the total capacity or max capacity, new object will be created and the process will continue. Though we have another constructor for this array list is ArrayList AL is equals to new array list of collection. This constructor constructs a list containing the elements of the specified collection. Whatever the collection you are going to provide, array list object will be created. This constructor is used to create an object for equivalent objects. Like if I want to convert a linked list object to array list or a vector to array list, that time this constructor we can use. So we have three constructors to create array list objects. That is ArrayList AL is equals to new ArrayList. It will create ArrayList object with initial capacity is 10. And second constructor is ArrayList AL is equals to new ArrayList of initial capacity. This constructor creates an ArrayList object with the specified capacity. The next constructor is ArrayList AL is equals to new ArrayList of collection. So by using this constructor, we can able to create the equivalent to the array list. If you see in this example, we have created array list object. ArrayList AL is equals to new array list. We are adding string. After that we are adding character. After that we are adding integer. After that we are adding string. After that we are adding null. After that we are adding true. So ArrayList accepts all type of data, that is heterogeneous data. When you print this size al.size, it is giving 6. So by using a size method, we can able to find how many elements are there. Here 6 elements are there. Here we are checking 1 2 3 object is there or not. See al dot contains of 1 2 3. By using contains method, we can able to check whether an object is exist or not in the array list object. So it is giving 1 2 3, this element is there, so it is giving true. Here in the next statement, we are trying to find the index of a. So we have given argument as a, so it is giving index is 0. This a is repeated in 2 times, but it is giving first occurrence of the object. So if we observe here, this array list object is accepting the duplicate elements also. And the next statement, if you see here, we have printed system.out.println of AL. We are printing the array list object. If you see here, A, B, 1, 2, 3, A, null, true. If you see here, the elements are displayed in the order which we have added. So first we have added A, B, 1, 2, 3, A, null, true. So the elements are stored in the same way, the insertion order it is following. And in the next statement, we are adding an element at the specified position. If you see here, we are adding an element at the specified position first index position we are adding. So here first index is 0 1, the is added in the first index. So after that we are printing, so it is giving A B 1 2 3 A null true. So by using this example we can say ArrayList allows heterogeneous data, ArrayList allows duplicate elements, ArrayList allows null values. And if you see in this example, we have created ArrayList AL is equals to new ArrayList object. We are adding A, string A, character B, integer 1 2 3, string A, null true we have added. We have printed that AL. So we are whatever the elements we have added, the same order it is printed. After that we are adding one more element by using index method, that is add of index 1. So if you see here, this element is added at the specified position, first index it is added. After that we are adding B character. So when you use normal add method, the element will be added at the end of the list. So when you print this one, the element B is added at the end of the list. We need some observation here. If you see here line number 15, what we are doing, we are adding element at the first index we are adding. In the before when we print AL, it is giving A B 1 2 3 A null true it is giving. When you add the is added in the first position. So when you add an element into the list, whatever the existing objects will be there, right, that all objects will be moved to the right position. That is, each object is moved to the next positions. So if you see here, B is shifted to the second index, 1 2 3 is shifted to the third index, A is shifted to the fourth index, null is shifted to the fifth index, and so on it is happening. And if you observe in the next statement, 18th line, and we are removing an object A, so this object is available at the first position, so it is removed. So if you observe here, when you remove an element, all the elements are shifted to the left hand side. Each object is, so if you see here, is shifted to the 0th index, B is shifted to the first index, 1 2 3 is shifted to the second index. So when you add elements or remove elements, the shifting of elements is happening. So based on these examples we can say add method takes order of one time. The time complexity for adding an element to the array list will take order of one time. Worst case scenario, when a new array has to be created and all the elements copied to it, its time complexity will be order of n. That is, once we created an array list object with initial capacity is 10, once the object is reached 10th position or max position, new array list object will be created, and all the objects, whatever the objects are there in the existing, it will be shifted to the new object, and the object will be added in the at the end. So this process, the worst case scenario, this add method takes order of n time. Next, add of index comma element. By using this method also takes time on average order of n time. That is, if you add an element in between the array list, so all the elements from where we are added, the from that position elements, all the elements are need to be right shifted. So that process also takes time. So the time complexity of this add of index element method is an average order of n time it will take. Remove method also take order of n time. Why? We have to iterate the entire array to find the qualifying for removal. That means if you are planning to remove an object, what will happen? It will be checked from the entire array list, it will be finded from the left hand side to right hand side, it will be checked, each object will be compared, and then if it finds, then it will be removed. and if you removed in between any element, all the elements also needs to be left shift also needs to be happen. So this remove method also take order of n time. The next is index of method. This index of method also take order of n time. That is, it iterates through the internal array and checks each element one by one, so that the time complexity of this operation always requires order of n time. The next is contains method. This contains method also implementation is based on the index of method. So it will also run order of n time. Get method. This get method is taking order of one time, because this array list object is implementing random access, so we can able to get the data easily. So this get operation will take the time complexity is order of 1. So based on these we can able to understand array list is performance wise good when the operation is reading the data, and when you are removing or when you are adding elements to the array list, that time the time complexity is more. This is all about this array list class in collection framework. Hope you found this video helpful. Thanks for watching.